markets. This is, for example, the SAGEM range of products, from pocket laser rangefinder down to long-range multifunction goggles. Okay, these are some examples of what is available on the market now. Multifunction goggles. You have the ranges for cooled uncooled technologies on the left side and cooled technology on the right side. What is the main difference between both technologies? Distance of acquisition, obviously, and related cost, which is not the same. So the French forces decided to balance what is available in the ordnance by bringing on board both cooled and uncooled technologies. This is what I was talking about. 6 sensors in a single equipment, which make any binocular a complete target acquisition station, and not only a mere goggle, with a weight that should be very, I would say, lightweight and appreciable by the soldiers carrying the equipment. Okay. The idea also is that we want to provide each soldier with the capability to utilize each function of the system by keeping at all time his hands on the weapons. Air warriors are very much familiar with a concept which is called HOTAS, which is hands on throttle and stick. And basically we wanted to bring this kind of concept down to the soldier. If you bring in a lot of functions to take a picture, to change the field of view, do this, do that, you want to still provide the soldier with the capability to engage at very, very short notice. And this is why we are mounting these specific handles or weapon handles to provide soldiers with this capability. This is an example. This is the example of the Swiss Army program that we got awarded in 2003. You can see the handle. Full interface with the weapon sight. The weapon sight also is interfaced through the system. Indirect fighting capability, which are very important. Deported vision, sector monitoring, support, and protection. This is an example of a man-machine interface. You can also use the indirect fighting solution through the basically helmet-mounted sight and display. Some examples of helmet-mounted sight and display, very much available and mature in the markets. Okay. Another aspect which is very important is C4I capability down to the soldier. The idea that we wanted to develop for the French forces is that everyone should be networked within the platoon to increase situational awareness, and in some cases to increase the continuity between mounted and dismounted troops. An example of a radio with ranges. Again, the radio should be operable through the handle, weapon handle, to provide the capability to speak while you hold the weapon, ready to engage. So it's a push to talk on the weapon handle. Okay. Each radio should be capable of send voice and data, provide conferencing, and so on. BMS, Battlefield Management System, which provide blue force, red force tracking. A key element in the development was to select what kind of function you provide to each soldier. Obviously, a section leader, a platoon leader should not have the same capabilities as a basic warrior. So we had a lot of development to tailor-made and to select the right functions at the right level. This is an example of how you integrate the platoon radio network within a company radio network through each personal radio of the soldiers. Platoon configuration, for example. Okay, before I take any question at the end of the session, I'll show a little movie to put all this into motion. So the idea is to extend the digitized battle space. Obviously, we use UAV reconnaissance now. So you can see the forces approaching the village with the UAV video available within the vehicle. Section leader preparing the mission on the BMS through the mission planning system. And this is very much available. This is what we are providing to the French forces now. Targeting through multifunction binoculars. Platoon is getting disembarked, ready to assault the village. With weapon sights. Uncooled multifunction thermal imager. Sharing observation sector. This is very interesting. You can see this mark on the upper side. Within the vehicle, the platoon leader has decided to assign observation sector to a dedicated soldier. Because the uncooled thermal imager is interfaced within the system, the orders of the platoon leader will be reflected within the Google of the soldier with these two marks on the upper side to allow him to fix and keep his sector observation. This is an example of what you can do with a fully integrated system. Remote survey through mini UAVs, or over the hill or over the village reconnaissance. Like I said, silent coordination through radio is very important through the osteophonic headband. Enemy identification to weapon sight by day and night. Friendly force tracking. Unmanned ground vehicles are also available in the market now. There are lots of vendors and manufacturers providing good solutions. Assault coordination through radio. This is the sniper special sights around the corner sighting through the specific man-machine interface. Thank you so much. So no body exposure. So it's a true around the corner or over the wall fighting solution. So after enemy is neutralized, soldier will take a picture with his weapon sight and report the picture to the section leader, platoon leader. So these are the technologies available now. Weapon sights with specific expert sights if required. Helmet-mounted night vision systems. Multifunction binoculars. Any kind of optronic sensors. Specific electronic vest with display, the system backbone. Dismounted battlefield management system. Individual GPS location. Video transmission of UAV or ground vehicle. Personal data and radio. Audio osteophonic headband. The remote control handle. With all kind of full ballistic protection, including NBC protection. And crowd control equipment if required. On-board video broadcasting of any kind of video, and remote weapon control, RCWS. So, and this will be my conclusion. As you can see, a lot of technologies are now available on the market. What is key is to strike the right trade-off, number one, to select the right people to absorb the technology, and special forces are rightly placed for that, and to integrate all this technology within a system. It's not advisable to bring every piece, each and every pieces close to the soldier without a sound system integration. Otherwise, you may end up with a huge cost, with a very heavy system, and with a cognitive ergonomy which will eventually hamper mobility, communication, and lethality, as well as survivability of the soldier. Thank you very much.
Yeah, this one. About 9.1, 9.3. Chairman, sir, ladies and gentlemen, the aim of my presentation in the next 15 minutes or so would be to give you an overview of soldier modernization technologies, highlight to you very briefly modernization requirements of a soldier across the full spectrum of conflict and technologies that are required to support this. I will also dwell briefly upon the Indian industrial capability to undertake this task. This was said by Lieutenant General J.F.C. Fuller almost 75 years back, that 99% of the battles fought in history have been won by the side possessing better technology. Almost a quarter of a century back, it is even more true today, because historically the Indian Army has always shied away from technology, mainly because such technology was not available to us. So therefore, we wanted to compensate the lack of these technologies by stressing on other aspects of warfare, which undoubtedly are equally important. Technology is advancing at a very, very rapid rate today, and it will be in the interest of the Indian Armed Forces to absorb and get as much as possible out of this. A soldier, my talk is going to be at the bottom of the pyramid, that is the requirements of a soldier. A soldier requires a wide spectrum of complex technologies which he needs for target acquisition, for individual weapon, situational awareness that includes computer, communications and things like that, protection, ergonomical clothing and equipment, and most important of all, power supply to sustain him throughout the operation. Briefly covering the technology to enhance target acquisition. We are required to enhance the soldier's sensory organs by means of optical systems in daylight, image intensification in darkness, and when that does not work out too well, and for longer ranges, thermal imagery techniques in period of darkness and poor visibility. Soldier has to be given the means to find his own position at all times in all possible situations. He should also be able to localize or find the enemy's position. He should also be able to designate, if not designate, point the position of this target to the rest of his colleagues. Very briefly about image intensification technologies. There are two parallel developments of technology, and very often the RFPs tend to mix the two together. One is the European method. The image intensifier tubes manufactured by Photonis or in Europe basically follow the XD4 type of technology, which is equivalent to Gen 3 of the US. Now it is further enhanced to an XR5 tube, which is a gated tube, and it gives you equal performance in day as well as night. However, this is not of any vital significance because optical sights are any day better in daytime than to use any such tube. The next development is Onyx. Onyx is the development of Photonis DEP, which is able to convert or which is able to give you a black and white picture. That is, white phosphor is used, and instead of giving the traditional green picture, it gives you a black and white, a clear picture. Coming to the US technologies, the most important of them is coating of the cathode by gallium arsenide. This enhances the life of the tube, although the magnification is reduced, but gives better life and also gives an equivalent picture as the XD4. So the point that I wish to emphasize is that you cannot have both. You can either have an image intensifier based on XD4 technology, or you can have an image intensifier based on gallium arsenide. Generally, we have seen, since I'm a part of the industry now, people tend to put everything into the requirement, and which is impossible to meet. Another point I wish to highlight is export restriction on the Gen 3 tubes. Very recently, they have cleared figure of merit of 1400, that is 1400. That technology is available. Anything better than that is not available for export. Image intensifier have a lot of problems or drawbacks. It depends upon the visibility conditions of the atmosphere. You cannot see through smoke. You cannot see when the light level is extremely low in a clouded starlight condition. You cannot see in dusk, smoke, haze, or fog. For that, you require thermal imagery techniques. It is required for longer ranges. It gives you better ranges, and it gives you the ability to see through atmospheric conditions which are not conducive to transmission of light. We have both types, cooled and uncooled thermal imagery for both day and night operations. Uncooled thermal imagery is advancing, the development is advancing at a very rapid rate. Today, they have almost reached the threshold of detection of cool technologies. The pictures are better and better. The resolution is much sharper and better. And you're almost reaching a stage where you can not only recognize, but you are able to identify a particular target, which was not possible in thermal imagery till now. Limitations. This is the limitation which is brought out by me, that you may like to use it on a sniper rifle, but the resolution may not be adequate to give you an identification of the target. Particularly in counterinsurgency and such roles, it may not be advisable to shoot by such a method. Latest in the world is fusion technology. By combining the two together, you are able to get the benefit of the positive points of both. You are able to get longer range, you are able to get a clearer picture when you fuse the two together, either by overlay or a more complex solution by digital integration or digital fusion. They are ideally suited for long-range applications and sniper sight, but point to remember is they are very expensive and may be a little more heavier than either of the two technologies. Next, we come to finding on position and location of the enemy. The entire world has come to recognize Nav-star constellation as the guiding force for navigation and finding own positions. We have to take this with a pinch of salt because particularly in special forces operations, the satellite signals may not be available to you, particularly when you're fighting inside buildings or inside narrow lanes and sub-lanes where you need certain number of satellites to get a fix that may be denied to you. So therefore, inevitably, GPS needs a backup. Also, please remember that the accuracies obtained by the GPS Nav-star constellation are coarse application or civil application, that is 30 meters for easting, northing as well as height. The precision application is not available to people who are other than allies of United States. However, our own satellite system may be able to overcome this problem, but it still needs a backup. It can fail you. You cannot really depend upon it all the time. In order to carry out navigation, if you don't have satellite signals, you definitely need a digital compass. You also need a digital compass to be able to find the direction of the enemy. A laser rangefinder, obviously to get the exact range to the target. Fire control computer for accurate delivery of a grenade on the designated target. Please remember that a fire control computer is not really required for direct shooting. But if you give the soldier a grenade launcher to take on targets which are defilated from view, and you want to give him airburst capability, then this requirement is important. Finally, a laser pointer which is able to draw the attention of the colleagues or of the rest of the squad towards the enemy that the soldier has detected. Laser designator, I would not recommend this because this is a heavy item. It is required to continuously designate a target to enable seeking ammunition to home onto it. So therefore, it's not really within the purview of the individual soldier. Coming on to the weapon, we need an integrated weapon firing kinetic energy projectiles, and also we need to give the soldier an ability to engage a target with indirectly with an explosive warhead. Ideally, this would be effective provided an airburst capability is also provided to the soldier. Weapon sight, nowadays optical reflex or red dot based or laser based holographic sights are available, where that strict training that is required to aim is not required. I have seen a novice who has never held a rifle before able to hit a target at 100 meters without firing a single round. So today, the technology enables a soldier to be able to aim with both his eyes open and engage a target at whatever distance. Of course, this is more applicable for shorter ranges. Now, supposing you have a day sight, it is not necessary to change this sight for a night sight. Today, add-ons are available. It could be thermal based or it could be image intensifier based. All you need to clip on this sight to your day sight and you get night firing capability. One of the drawbacks is when you change a sight, you have to zero the weapon all over again. It could of course be done by the means of a laser, but invariably you will have to go out and fire a few rounds if you want to have the same confidence in your weapons. You need to have a laser range finder and a digital compass also to be built into the sight. If you have all the kinds of night vision devices on the helmet and on the weapon and all over, you will have a number of displays. It will not be possible for the soldier to be able to concentrate on this. So therefore, there is a requirement of connecting all these or integrating all these by help of Bluetooth and providing a soldier with a helmet display system with which he can select the output of the sensor that he requires. Point I would like to mention is that helmet mounted systems are still extremely expensive today, and one has to think you may not be able to provide this capability to each and every soldier. Coming on to weapons, you require carbines to deliver